Okay, so this is the first of two linear programming videos that you'll watch. The first one is just bare naked linear programming. Linear programming, as you can see in the definition right here, is a type of optimization process. It's designed to find the minimum or maximum value of a given quantity. Linear programming is how companies find ways to maximize profit, to minimize costs, etc. We're not going to look at any of that today. That will be tomorrow in word problems. There are two things that are important, and these should be listed backwards. So I would say the number one thing we're going to look for is an objective quantity, the equation that represents cost or profit, and then we'll look for constraints, system of linear inequalities. And I think I'll pause right now and just tell you these notes, if you pause and go back to Moodle, there's a copy of these, so you'll have all the graphs that are coming up. If you print them out, then you can just take the notes right on this paper. There are 3 steps to solving a linear programming problems without word problems. 1, we're going to graph the systems. 2, we're going to find the vertices, the corners. 3, we're going to plug them into the objective quantity to find the max and min. And that will make no sense to you until you see a problem. So here's our first one. We're trying to find the maximum value and the minimum value of the objective quantity. Now right here I'm given an objective quantity, P equals 20 times X plus 40 times Y. P typically stands for profit, but obviously in here P doesn't stand for anything because I don't have words. So I am going to graph my inequalities. So I'm going to graph X is greater than 3, greater than or equal to 3. That's going to go this way, and this will be very helpful if you do it in color. Y is greater than or equal to 0. Now I don't care about shading over here, so I'm just going to shade where the red and the blue would cross. This last equation here, I'm going to first solve for y, and don't forget in inequalities if I divide by a negative, I'm going to flip the inequality. This is not going to be dividing by a negative. So the purple line begins at 4 and has a slope of negative 2/3, and it's less than or equal to, so it's going to be here. So you can see that my shaded region is where everything is right in this little triangle right here. So the next step is I'm going to find the corners. So I know I have a corner here at 3, 0. I have another corner right here, whoops, at 3, 2. And my other corner, this is a terrible graph. This purple actually should come down here and hit right here, which would be 6, 0. Now I'm going to take each of these corners, okay, again these are called corners, and I'm going to plug it into my objective quantity. So I'm going to take this corner and plug it into this objective quantity. So I get 20 times 3 plus 40 times 0, that's going to give me 60. I'm going to take the next corner, 20 times 3 plus 40 times 2, and that's going to give me 140. And the last one, 20 times 6 plus 40 times 0, and that's going to give me 120. And you can see right here would be my max, and right here would be my min. So the minimum value of P is 60, where X is 3 and Y is 2. The maximum value of P is 140, whoops, where X is, this should be a 0. Sorry about that. And 140 is where x is 3 and y is 2. So let's look at one more real quick. I want x to be greater than or equal to 2, which is going to go this way. Okay, and again, I just want to make sure that I see my objective quantity right here. C typically stands for cost. I have 4 different inequalities that I'm going to graph here. I want x to be less than or equal to 5, which is going to be right here. Narrowing down my corners. I want y to be greater than 1 or equal to 1. So I'm going to go this way. But I also want y to be less than 6. Which is going to come down this way. So this whole area is going to be my shaded region. Okay? So now I need to find the corners of that region. And that's going to be 2, 1. That's going to be 5, 1. That's going to be 2, 6. That's going to be 5, 6. And I'm going to plug these into my objective quantity right here. Sorry, that keeps sliding. Right here. So I get 2, 3, plug in 2, plus 4, plug in 1. It's going to give me 10. 3, plug in 5, plus 4, plug in 1. It's 19. 3, plug in 2, plus 4, plug in 6 is 30. 3, plug in 5, plus 4, plug in 6, and that's going to give me 15 and 24, which will give me 39. So the minimum value is going to be right here. The minimum value is 10 when x is 2 and y is 1. The maximum value is here, 39, when x is 5 and y is 6. So just to really quickly recap what this is, we are doing linear programming, which right now just looks like a whole bunch of inequalities. I need an objective quantity, I need constraints, and I need to find the min and the max. I shall see you in school tomorrow.